Okay, so in this problem, the standard basis is for s, the polynomials of degree 3 is 1x, x squared, and x cubed. Our given basis is x squared minus 1 and x squared plus 1. So we want to determine if this is enough to span the three-dimensional, or P3, which is really four-dimensional with this basis. And if not, then we need to extend it to P3. So that's the goal for this problem. Okay, so if we write our bases, x squared minus 1 and x squared plus 1, in terms of the standard bases, we would have negative 1, 0x, 1x squared, and 0x cubed for the first one, and x squared plus 1 equals 1 plus 0x plus x squared plus 0x cubed for the second one. To convert this into a matrix, we're going to first make it into a column where the basis in this form follows the same standard basis as up here. Okay, so these two then become our columns. So our matrix becomes negative 1, 0, 1, 0, 1, 0, 1, 0. Okay, so we will check the row dependency if this is linearly independent or not, or if one is a linear combination of the other. As we can see already, since we're looking for a third degree polynomial and we do not have a third degree, we will need to append this to the identity matrix for P3, which is going to be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, and then we'll perform row reduction on this one as well. We're going to do both of these. We're going to check both of these in GeoGebra instead of doing it by hand here. And then what we'll find is which of these vectors do we need. In other words, which of these sets from S do we need in order to extend this basis to span all of P3. All right. I hope that's helpful, and I'll see you in GeoGebra. All right, so for this problem, here we've entered in the two-column matrix, and so we're going to look at the reduced row echelon form of this. So we see that these two vectors are linearly independent. I think we've shown this in a previous example. So now let's append the matrix to it and see what we need, what the vectors from P3 we need to extend to this system. I'll be quiet and go through this real quick. So here we have the identity matrix, and this is our augmented matrix. So here's our two vectors, negative, or x squared minus 1, if you will, and x squared plus 1. And then here's the identity matrix here. Okay, so we're going to go ahead and look at the reduced row echelon form of this, and we see that M1. Okay, so here we see that we need the it looks like we need the second column and the third column of the identity matrix for P3 in order to extend this system to the basis set for all of P3. Right. I hope that was helpful, and see you in the next video. All right, from GeoGebra, we saw that the augmented matrix gave us this. So our values here and here are going to be our necessary extensions from this. So that means we're going to need the x vector and the x cubed vector in order to write this basis. And so our basis set B, once it is extended to all of our bases, okay, is going to then be, we have the x squared minus 1, x squared plus 1, the x vector, and then the x cubed vector. So those are the four vectors that we need given our original combination to extend to cover the basis for P3. So this is the basis for P3. Okay, so we have 4 linearly independent vectors that span the entire space. And that's what we needed. All right, I hope that was helpful, and I'll see you in the next video.